Welcome to the project demonstration of multi-thread surveillance robots for military applications. So in this project, main applications are we are using multiple sensors to detect the multi-threads, nothing but gas, smoke and metal detected. Whenever the harmful gases leak near the robots or any smoke detected, and if is any metal detected while the robot is driving. So based on these three sensors, we are going to detect the threads, and the same will be uploaded to the web page. Those who are controlling this robot movement from the browser, so we can get the location of this particular vehicle and the status of the gas, smoke, metal. So 0 nothing but no threads, 1 nothing but the respective sensor is detected. And also continuously we are going to get the surveillance, nothing but video streaming with help of this ESP32 camera. So and all these sensors and input output modules are interfaced to the ESP32. So here the main features, as we discussed, the sensor part and robot movement part was interfaced to the ESP32. So for example, so here the gas, smoke, metal sensor are interfaced to the ESP32. So smoke sensor at pin number 18, gas 39, metal 36, buzzer audible alert. So whenever this is detected, you will get the audible alert through the buzzer board, and interface to that 23rd pin, and GPS at the transmit receiving pin of our ESP32, and 25, 26, 27, 14 pins for this L298 motor driver, and ESP32 camera interface to the transmitter pin and receiving pin or interface to this. So here whenever we are providing the commands to control this robot movement, forward, backward, left, right, stop, so these commands will be sent from the ESP32 camera to ESP32 module. So we are using the ESP32 module here. At the same time, whenever this gas sensor status or smoke or metal sensor status will be getting from the ESP32 to the ESP32 camera, and that will be uploaded on this browser. So this is the bidirectional full duplex communication between the ESP32 and ESP32 camera. So these are the main features of our project. Coming to the components, so here mainly we are using the battery power, so which will driven to this robotic movement, and the battery rating, sir, we are using 12 volt 2 amp. So coming to the battery pack, so we are using 6 battery pack, 6 batteries. In that one, 3 are in series and 3 are in series. Each cell is 4 volt 1 amp. So this is the 12 volt 1 amp, and this one is the 12 volt 1 amp. These two are in parallel, so we'll get 12 volt 2 amp DC output. So that is the operating voltage of our motors, nothing but robotic movements, and that is the input to the L298 motor driver. And coming to the remaining components, operating voltage is 5 volts. So in order to regulate that 5 volt from 12 volts, we are making use of this LM2596 voltage regulator, which will take 12 volts DC input and provide us the 5 volts DC output from there to this breadboard. So from this breadboard, we are distributing that throughout the input output modules of our project. And as we discussed, not only the sensor status, we are going to get the robot status from this GPS antenna, and this is GPS processor, and this is the ESP32, and next L298 motor driver, which is used to control this more robot movement. In that we are using the 4-wheel drive. These two are in parallel, and these two are connected in parallel. So these 4 motors connected to this L298 motor driver at motor 1 slot and motor 2 slots, and the buzzer is connected to the ESP32 at the respected pin as we described, so to get the audible alerts. And this one is the gas sensor that we mentioned, gas, smoke, metal, and finally ESP32 camera. And the main thing is the battery charging. So before demonstration of the project, the very first step is keep the battery under full charge. So it will take around 4 to 5 hours to be get fully charged, so that if it is fully charged, we can get up to 3 hours of backup. So to charge a battery pack, you just connect the battery at this slot 2 pin as we shown here, right? So connect this, and now on the power supply to this transformer 230 volts AC inputs. So now the charger is getting on, as you can see the light indicated. So till the mentioned duration, we should keep the battery under charging. Once the charging was completed, you can just disconnect this. And now let us check the demonstration. So the next step is to communicate through Wi-Fi. We need to enable the hotspots. For that, we need to configure a specific name of project 7159 without any space, without any capital letter. Password should be 123456789, and AP band should be 2.4 gigahertz. So after enabling the hotspot and data, now we need to install one more application, that is network analyzer application, the icon of this application from the Play Store. So after installation of this one, this is to get the IP address of our ESP32 camera once it's connected. Some mobile phones shows directly IP address in the settings section only after device got connected. Right, wait here. Now after all these settings successfully done, now on the power supply, this is the main on off switch. So after that, right, so if it is on runningly, just reset that. So it's a reset switch. As initially the ESP32 camera need to connect to the Wi-Fi, then it will send the junk data to the ESP32 camera. So then, sorry, ESP32 module. So once the pairing successfully done, then just reset this ESP32 module. Okay, and we can see one device is connected in your mobile phone. So to check the device IP address, options, LAN scan, scan here, and we get 2 IP address and off the Wi-Fi, so that you will get the specific IP address of our ESP32 camera. So this is our mobile phone IP address, and this is the ESP32 camera. Just click on that and open in the Google Chrome. So directly we are going to getting the streaming. Okay, and we can on the headlights, off the headlights. Okay, and robot movement also. So forward motion, backward, stop, left side, right side. And along with the controlling in the full duplex communication, as we discussed, we are going to get the sensor status also. Right now let us check the input to this. So when the smoke detected, so we can see one light is on this backside of the sensor along with audible alert from this buzzer, and we can see the status on this browser also. You can see that. Sorry, yeah, right, there's a misconnection. So it's actually smoke sensor, it's a gas sensor. Yeah, this is. Yeah, so now the connection changed now. Yes, you can see that this is a smoke. So you can see the smoke status is 1 in our browser also. Till the smoke detect continuously, the LED on the back side of the sensor, and as well as here the status also showing the 1 here. Right, so this is about the smoke. And coming to the gas, so we are using this MQ6, which is a combustible gas sensor. It can detect the methane or any other sensors, any other gases also, but for demonstration we have the LPG for demonstration. Just we can see same it is also. So the light gets switched on back side of this one, and the same status on this gas is 1. And when the gas concentration decreases, it will back to the 0 and buzzer will be off. Till that we can see the right now it is 0. And coming to the metal detection, okay, right. So now let us check the output on the floor. Now let us check the output on the floor. So headlight also on, right. Right, okay, thank you.